Hey guys, it's Sedes, and welcome back to my channel. Today we're going to have an intro to derivatives. Now, derivatives are this scary looking thing over here. D over dx, or you've probably seen f prime of x, or you've probably seen a dot dot dot. All these things mean derivative. Now, all derivative means is rate of change. So think of it as a slope. Now, if you have seen my limits video, you'd know that a limit is when x approaches some number that it just can't equal because of the constraints of the equation. For example, limit as x goes to 3 of 1 over x minus 3 is a limit that x can't equal 3, because if x was 3 here, then the denominator is 0, and you can't have a 0 in the denominator. So what you would do here is evaluate it from the left, which would be some number that's slightly smaller than 3, right? Which would just mean that this number here would be like 2.9, for example. And this would just be a really small number, which would make this in turn a really small number, which would then be a negative of some really small number over 1, which just equals negative infinity. Because a really small number over 1 over a really small number is a really big number. Now, if you evaluate it from the right, it's going to be slightly bigger than 3, so it's going to be a positive number here, because it would be like 3.1, for example, minus 3, so it would be slightly bigger than 3. So it would be 1 over a really small positive number, which would equal infinity, which means this limit is not continuous. It has no answer. Anyway, all that to say, limits can help you find the derivative because limits can calculate slope. So the slope of some function of x is equal to the limit as h goes to 0. Well, I shouldn't put f of x here. I'll put m. It equals f of x plus h minus f of x over h. Now, the reason this is a problem, obviously, is because there's an h down here, and h is approaching 0. And if h is approaching 0, h can't be 0 here. Now, I'm going to give you an example of this. So, if our function is x squared, for example, you just have here by the way, this slope is just also known as aka derivative. I'm just going to put aka derivative here. Now, if you plug it in here, it just equals the limit as h goes to 0 of x plus h squared minus x squared over h. Now, x plus h, if you've seen my other videos, you know that a plus b squared equals a squared plus 2ab plus b squared. So, this x plus h just equals limit as h goes to 0 of x squared plus 2xh plus h squared minus x squared over h. Now these x squareds cancel because it's x squared minus x squared, and then you have 2xh plus h squared. Take out an h from both, and then you have h, and then you have 2x plus h here, and then h over h cancels, and then you just have 2x plus h, and it's the limit as h goes to 0. And if you plug in h as 0, then you just get 2x, and that is the derivative of x squared. Now, you don't want to do that every single time you take the derivative of something. Because if you have, for example, like, I don't know, x squared plus 7, you don't really want to calculate that, do you? Now, I'm going to teach you some of the rules. So, basically, the derivative... Now, the reason why it's written like this is because it's the derivative in respect to x. You can have the derivative in respect to other variables as well. Like, I don't know, you could have normally in this case, it would be d of dx of some function of x. It could also be d function of x in respect to x. So this just means the derivative in respect to x. Right? So I'm going to teach you some rules. First is the power rule. So d of dx of x to some n is n x to the n minus 1. For example, the derivative of x when x is 3 is equal to 3x to the 2. This also works for negative numbers. So if it's x to the minus 3, it would just be minus 3x to the minus 4. Because minus 3 minus 1 equals minus 4. Keep that in mind. Now, next we're going to talk about the additive rule. So the derivative of, not n, of x plus n would just be x, because in this case, n isn't changing x at all. N is only, if we look at a graph here, like let's say this versus like this, they're the exact same graph, but n just displaced where it is. Now n is always, in an equation, if it's not touching x here, it's going to change the height of the function. But regardless, the slope of the function does not change at all, because these are the same functions, they're just at different points. The function is at a different point. So the derivative makes you lose information because you don't know where the function is happening, but you know the slope of the function, which is what the function is going to look like. Now, the derivative, subtraction is the same thing, by the way. Now, if you have the derivative of, let's say, x squared plus x, you're going to have it's commutative, so it will be the derivative in respect of x squared plus the derivative in respect to x of x. And we already know what this is. This is just 2x, because it would be d of dx of x to the n equals n x to the n minus 1. And this would be 2x, and here it would just be 1. So this would be the derivative. Now, talk about addition. Subtraction is the exact same thing here. Now, if your x has a quotient, like d dx of 2x, it would just equal 2, because this quotient does change things. So if you had 2x, you'd have this case where, alright, so this is what a normal xy graph would look like infinitely. Now if you had 2x to y, the slope is like 2, so it would be more angled like this. Right? So it does change the x since it's attached to this x over here. Which is why it equals 2 here. And so if you had d of like dx of 2x squared, it's the same as 2 times d dx of x squared, which is just 2x. So the derivative of this would just be 4x. Right? Now, there's also the quotient rule, or the division rule. So the derivative in respect to x of, let's say, I don't know, x squared over x cubed. Or actually, I'll do this in functions of different functions. So d of dx of f of x over g of x equals f prime x g of x minus g prime x f of x. By the way, these are multiplied over g squared. So x squared over x cubed equals the derivative of x squared, which is 2x, and then times x to the third, minus 3x times x squared, all over x to the 6th. So in total, this would just be 2x to the 4th minus 3x cubed over x to the 6th. We could definitely simplify this, take an x cubed out. 2x minus 3 over x to the 3rd. And then both of these are times x to the 3rd. Cancel those out, so your final answer would be 2x minus 3 over x cubed. Now the thing is, for any quotient, you can just turn it into terms of the power rule. So it could just be d of dx of x squared times x to the minus 3. Right, which would then just be product rule. And product rule, in this case, would be if you were doing the product of something, of, let's say, f of x times g of x, it would be the derivative of f of x times g of x plus the derivative of g of x times f of x. So in this case, this would be 2x times x minus 3 plus minus, it would be minus 3x to the minus 4 times x squared, right? And then you would get here, you'd get 2x to the minus 2 plus, minus 3 times x to the minus 2. So that would then just translate into 2. Okay, wait, x over x cubed is just 1 over x squared, and x squared over x to the 4th. That's weird, wait. Right, this was x to the 6th, and then you have 2x times x to the 3rd minus 3x squared and you have 2x to the 4th, 3x to the 4th. No, yeah, this is right. I just freaking screwed myself over. Frick. But regardless, this is also another way to figure out the answer to the equation. Now, I believe that is all you need to know about derivatives, unless you guys, like me, love trigonometry. And I love me some trigonometry, so we're going to do some derivatives of trigonometry. Now, the derivative of sine of x equals cosine of x, and the derivative of cosine of x equals negative sine of x. That's what they are. Now, the derivative of the tangent of x, you can derive it and just do sine x over cosine x, right? And just do either product rule or quotient rule. I'm just going to tell you flat out, it's secant squared x. The derivative in respect to secant eighth is secant x tan x. The derivative in respect to cosecant x is negative cosecant cotangent x. By the way, these both have a function inside them. And the derivative in respect to cotangent x is negative cosecant x squared x. Okay, all of those. And finally, one more thing is, or two more things actually. So, actually 3 more things. So, you know what? Scratch that, 4 more things. So, constants don't have a slope because they don't revolve around the x at all. So, the derivative of a constant is 0. The derivative of e to the x is always going to be e to the x, just because e to the x just does not change. That's the definition of e. It doesn't have a difference in rate of change. It's the graph where, no, that's log. It's a graph where the slope is equal to the I don't remember all about e right now, but it's in relation to the slope is equal to something else about the graph. Regardless, this is just what it is definitionally. And finally, we got to talk about chain rule. Chain rule is basically when there is a function inside of a function. So, I don't know, x squared plus 3 cubed. Now, this just means if we were to put this out definitionally, it would just be f of g of x, right? That would just be the derivative of f of g of x times the derivative of g of x. So it's like a nested kind of function here. So in this case, it would be 3 times x squared plus 3 squared, and then it would be times 2x. So this would be the answer to that chain rule function. And that is all my math for today. See you guys later.